recording, and then I'll share my screen. So if you can see the screen, say yes in the chat. If you cannot see the screen, say no. So can everybody see the screen? Yes, okay, very good. So let's just start. Today is the fourth lesson, and I think the final lesson of conic sections, which is what we've been working on these past few weeks, right? So this one is about hyperbolas, the final type of conic section that we are going to learn about. So last class was a long weekend, so a lot of people were gone. So hopefully everybody looked at the recording and they learned about ellipses. So today we'll be reviewing some of the ellipses, and then we'll also be going to hyperbolas, which is the final conic section. So first, let's go over the homework, and then we'll start. So the first homework question is to write the equation of the ellipse with endpoints of minor axis at -2, 2 and -2, 4, and the focus at 2, 3. So make sure you did this, or if you have not done this yet, make sure you do it now and put the answer in the chat. All right, so let's go over this one. So let me choose someone to do this for me. So who can do this? How about let's see, Kaylee. Kaylee, are you able to do this problem?
Okay. Um,
So first, let me just draw the coordinate plane here and plot these points, right? So it's like -2, 2, and then -2, 4, right? So that is the length of the minor axis.
it's 2. 2 is the length of the minor axis.
So 2 is the length of the minor axis. And how do we find, so we know that the equation of an ellipse is what? It's like x minus h squared plus
Over
y minus k squared over
a squared plus
b
b
squared is equal to 1,
equals
right?
1.
Well, of course, a squared and b squared can switch or something, right?
Mm-hmm.
But it seems that the minor axis here is vertical. And we know that the minor axis is equal to what?
B.
2b to be exact, right? 2b. So that's length, right? B is only 1/2 the minor axis. So 2b is equal to what?
2.
Right, so b is equal to 1. And we know that b is equal to 1 now. And we also know that the minor axis is vertical, which means that b is under y and a, which accounts for the major axis, must be under x. That means the major axis is horizontal. Right. So then it says we have a focus at 2, 3.
Um,
Okay, something went wrong here. I think I meant center. The center. Or, yeah, that shouldn't be correct.
do you mean negative 2, 3 then?
-2, 3? Oh, did I write it? Did I write it wrong? -2, 3? Oh, wait, no. This is correct. This is correct.
Okay.
So this is, oh, it's here. Okay, so yeah, that was wrong. So the focus is at 2, 3, not -2, 3. So that was wrong. So this problem is still correct. So we know that b is equal to 1. And we don't know a, but we know it's under x, right? We
Mm-hmm.
also don't know the center yet, but we can find it. But we know c because we're given the focus, and the focus is going to be on the major axis, and it's going to be c, right? So c is going to be the distance from here to here, and that's 1, 2, 3, 4. That's 4, right? So therefore, c is going to be equal to 4, right?
Yeah.
So if we go the other direction, the length of the foci, the distance between the foci is going to be 2c. So that's our foci, but our vertices are also outside of that. So to find a, how do we find a? Do you remember how to find a?
Not really.
So we need to use this relationship between c, b, and a. Once we have two of them, we can find the third. We know that c squared is equal to a squared minus b squared. So now you know how to find it, right? So what is a?
16 equals a squared minus 1. A squared is
Therefore,
equal to 17.
square root of 17.
Yeah.
So square root of 17, let me get out my calculator. Should be it's 4.12. So as we can see, 4.12 is just a little bit further than the foci here. So that's exactly what it's going to look like. So we have a very wide ellipse here, and that's going to be A. So I think the graph should be like this, right?
Okay.
Make sure you always include the foci here, F1 and F2, because the foci are very important when you get into something like physics, or optical engineering, because they create lenses with the ellipses and hyperbolas, that kind of stuff, because of the light refraction and the distance between the foci. So make sure you include the foci when you're graphing it, because they determine the shape too. Now that we found A and B, we can find the center now. But obviously, the center is quite easy to find because it's just in between. It's just in the middle of the axis. So it's -2 and 3 here. So that's the center. So with all that information, Kaylee, what is the equation of this ellipse?
Um, x plus 2 squared over 17 plus y minus 3 squared over 1 is equal to 1.
Very good. So actually, you don't even need this one. Just leave it as it is. So y minus 3.
Okay.
So yeah, that's how you find the equation of the ellipse. So let's do this next problem here. An ellipse has vertices 3, 1, and 9, 1, and passes through 7, 3. Write the equation. So this is a very similar problem, right? It shouldn't be too hard. I'll give you like a couple minutes if you haven't done it yet. If you have done it, please put your answer in the chat. All right, so let's go over this one. So let's see who can solve this next one. So are there any volunteers that would like to help me solve this one? Or maybe you've done the homework already and you know the answer. So let me see if anybody posted something in the chat. So let me see here. How about Eric? Eric, are you able to help me on this problem? No? Okay, how about Andy?
I wasn't here last class, so um, yeah,
Did you watch the recording?
I watched a little bit, but I didn't really.
All right, I'll help you through it. Okay, so let's look at this problem. Right, an ellipse has vertices 3, 1, and 9, 1, and passes through 7, 3. Right, you have to write the equation. So this is a pretty simple problem actually. So let's just have our coordinate plane here and plot our points. So 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So this 9, 1, and this is 3, 1, right?
Mhm.
By vertices, it means major axis vertices, right? And we know what is, did you learn the length of the major axis?
Yeah. Wait. Yeah, it was. It was a 6. 6.
So the length of the major axis is 6. And
Yeah.
that's also equal to 2a, right? So what is a?
3.
3, very good. So
Yeah.
obviously we have this here. Okay, and we don't even need to find c, right? We don't necessarily need to find c. Let's find the center. So what is the center here?
6, 1.
Very good. So 6, 1 is the center. So you know the equation of ellipse, right? X minus h squared over a squared.
And then
And
y
then this is plus
minus.
y minus k squared over b squared is equal to 1, right? So
Mhm.
we know a, right? It's 3. It's 3. So we have x minus h squared over
Over 9.
9 plus y minus k squared over b squared is equal to 1. However, we also know the center, and the center is equal to hk. So we have hk here, and that means we can actually substitute this h for 6. You can also substitute this k for 1. So the only thing we don't have is what? B, right?
B. Yeah.
How do you suppose we could find B?
By drawing the parabola with 7, 3, and
Right. You're going to use this point, right? Obviously. So what you can actually do is, you know that this ellipse passes through 7, 3, meaning that it's a point in the ellipse. So it's also a part of this equation. So what you can do is you can substitute x and y for 7 and 3. So you can have 7 minus 6 squared over 9 plus 3 minus 1 squared over b squared is equal to 1. So obviously this becomes pretty easy. We have 1 over 9 plus that's 4 over b squared is equal to 1. Can you solve this?
yeah. Wait. Yeah. Okay. So 1/9.
So what we
So
need to
is it
do
square
is
root
we
of
need
2
to
over 3?
combine the fraction, right?
The square root of like 2 over 3?
Well, we take this, right? 1/9
Huh?
plus 4 over b squared is equal to 1. Let's say we can combine these fractions, right? Or we could do something else. We could multiply, since you see these, you have a denominator here, right? So what we can do is what?
Find the common.
We can multiply this,
Yeah, find the common denominator.
right? Multiply this by 9b squared. It's going to be b squared plus 36 is equal to 9b squared. So 36 is equal to 8b squared, right?
Mm-hmm. Oh.
So how would you find it out? Well, you just divide by 8, right?
8 and then
So
square root it.
right. So I think that's 9 over 2 is equal to b squared. And you don't even need b. Do you even need b? Because we only need b squared here. So
Oh yeah.
essentially, we divide this by 9 over 2. But since we can't have a fraction in the denominator, we have to flip this upside down. We have 2 over 9 here. That is how we find the equation of the ellipse, right? So it's pretty simple, nothing too hard. Just make sure you know that how to find A, how to find B, how to find C, all the relations and stuff. And our last one here is the easiest, actually. Write the equation of a circle with the center at 3, 5, and is tangent to the y-axis. So actually, I'll just go over this real quick because we don't even really need to do much with this one since it doesn't really relate to ellipses. But that's just a little bit review on the circles and tangent, right? So obviously the center is at 3, 5. And it says it's tangent to the y-axis. Now tangent means it touches, right? So we know that the circle at some point is going to touch this point on the y-axis. But that also means that the radius is equal to 3. The radius is equal to 3. So if you go up by 3, the radius here is also equal to 3. Radius here is also equal to 3, right? It's also equal to 3. So that's just our circle here. That's what the circle looks like. And the equation, x minus h squared plus y minus k squared, y minus k squared is equal to r squared, right? Then we write the equation because we know that r squared is equal to 3, or 3 squared is equal to 9, right? And we have x minus h and y minus k that we don't know, but we do know the center, and we can just plug that in. So center 3, 5 is equal to h k. So we have x minus 3 squared plus y minus 5 squared is equal to 9. So that is the equation. So are there any questions over their homework? So if you have any questions over the homework, please put those questions in the chat now. All right, so if there are no questions, okay, very good. So now let's continue to what we're going to actually do today. So we just went over the homework, so let's review a little bit about ellipses for anybody that did not come last week. So the definition of an ellipse, we're going to review. So, and we want to review this because we also want to compare this to a hyperbola. So a hyperbola, actually, what we're later going to learn today is going to look like this. What does this look like? It looks like two parabolas reflected, right? But the thing is, a hyperbola is actually more related to an ellipse because of the foci and how the relationships between C, A, and B. So we're going to compare these three conic sections. Okay? So an ellipse is a set of points p, x, y in a plane such that the sum of the distance from P to two fixed foci is constant. Okay? So that means if we have an ellipse here, an ellipse kind of looks like an oval. It actually is an oval, I guess. So you have our foci here, F1 and F2. Basically, this is a set of points P, X, Y, such that the sum of the distance from P to those two fixed foci is always the same. So here, see the distance here. The distance from P to F1 plus the distance from P to F2 is constant, right? So no matter where you move this point, the sum of those two distances must be constant, and that is an ellipse. We know a couple of things about this ellipse. The first thing is the major axis. The major axis will be the longer axis. So as you can see, the x-axis right here is the major axis. The minor axis, of course, is the smaller axis. It's a minor axis. And the length of the major axis is equal to 2a. Length of the minor is 2b. And the distance from the center to the foci is c. We also know that c squared is equal to a squared minus b squared. And you need to remember all those relationships. So with this, we know the 2a, the 2b, the c, right? And we can make an equation out of that, right? X minus h squared over a squared is equal to plus y minus k squared over b squared is equal to 1. And this is not actually a set equation. This is what we think of first, but there's also a possibility that x, that's like this, b squared plus y minus k squared over a squared is equal to 1. And since a is always greater than b, whichever variable, x or y, that a is under, that is the variable with a major axis. For example, if a is under y, then the major axis is vertical. However, if a is under x in this case, then the major axis must be horizontal. So that is the equation of an ellipse. And let's see for the hyperbolas. Hyperbolas is a different story. It's very, very similar, but it's just that the operations are a bit different. So let's see the definition of a hyperbola. That is going to be set of all points in a plane such that the difference between P to F1 minus the distance from P to F2 absolute value is constant. So I just explained what a hyperbola looks like. Right? So A hyperbola, let's just use this type as an example. A hyperbola has basically two identical parabolas just reflected off of each other like this. This is f2, this is f1, and we have a point here, pxy. What this definition is saying is that this is d1 and this is d2, that d1 minus d2 is constant always. No matter where you move p, if p is over here, the difference of the distances is still going to be a constant. So now that we know what a hyperbola looks like, let's go over the values that make up this hyperbola, and it's actually very similar to an ellipse. So let me just erase this real quick, make up some space. Right. So there are a couple ways, actually two ways, that a hyperbola can be constructed. One way is that the hyperbola opens left and right. So we have a couple of things here. So if it opens left and right, obviously the major axis is going to be horizontal, right? So it's not really called a major axis. The major axis that we use for an ellipse is called the transverse axis. And the minor axis that we know is actually called the conjugate axis in a hyperbola. It's kind of weird, but that's just how it's called. So obviously, if it opens left and right, the transverse axis is going to be horizontal. But if it opens up and down, opens up or down, okay, hold on. Yes, if it opens up or down like this, then obviously the transverse axis is going to be vertical and the conjugate axis is going to be horizontal. So now you're going to ask, why is there a box here? So this box is actually a tool that we use when we're drawing a hyperbola to help us orient this graph. So let me first go over the parts of this hyperbola, like A, B, and C. Where are they? So let's just use this example for now. So let's just draw our imaginary box here, and this helps us graph. So if you don't like it, you can always erase it later on, but it helps us graph. Basically, what we do with this box is we connect the corners to make asymptotes. So everybody remembers what an asymptote is, right? It's this line that you cannot cross, right? So our asymptotes are there, and this is going to be a vertice, right? This is going to be a vertice. So this is a vertice, and let's say it opens here, and this is our foci, focus 2, focus 1, and it opens like this. You see the point of the asymptote, right? It's to make sure, it's to kind of guide your graph. The asymptote, you can't cross that line. You can't cross it. So you see how it guides the graph here, right? The graph, it follows the asymptote line, right? And of course, the foci are outside of the vertices this time, right? So this distance is going to be A. This distance is going to be C. This distance is going to be B, right? The minor axis is still going to be 2B. the major axis is still going to be 2a, or the transverse and the conjugate axis. But the relationship between a and b and c is going to be c squared is equal to a squared plus b squared. And a squared is always under the positive function. I'll talk about that later. Not function, it's fraction. So why is it always under the positive fraction? So what does the equation of a hyperbola even look like? It's going to look like x squared over a squared minus y squared over b squared is equal to 1. Or y squared over a squared minus x squared over b squared is equal to 1. So the positive fraction is going to have the conjugate axis, no, the major axis or the transverse axis, right? So a is always under this positive fraction. So since x, right, in the first equation is positive, then the transverse axis is going to be horizontal. However, since y has a and it's positive, it's going to be vertical, right? The transverse axis. In this case, a does not have to be greater than b. A can be less than b, right? So just remember that a is always under the positive fraction in that c squared is equal to a squared plus b squared, because as you can see, the foci is longer than a. C is bigger than a. So it's going to be c squared is equal to a squared plus b squared now. And it's not necessarily the Pythagorean theorem, it's just the relationship between a, b, and c. So let's go over some practice problems. What you're going to do is you're going to graph this. So I know we just learned this, but let's see if you can try a little bit of this, right? So first, of course, you need to make sure this is in the equation. Of course, now this equation I forgot to add, of course, you can have x minus h squared minus y minus k squared over a squared over b squared is equal to 1. This changes the center. Change the center where it is, that's all. So make sure that this is in the correct form, and then you can graph. All right, so let's find a volunteer to help us with this problem. So how about William? So William, can you solve this problem? All right, William.
Okay, I'll try.
So first of all, this should be in the first part. Well, the main part actually should be the easy part for you, right? Because you
Yeah.
already know how to complete the square. So let's complete the square here.
Okay, so we have to complete the square for 9x squared minus 4y squared. So we have to divide everything by 9 and 36. So it's 9 times x squared minus 4x. And then minus 4y. Minus 4y squared minus 6y. Is minus
So plus
36.
plus 6y actually.
Oh yeah. So plus 6y equals 36. Then now we can complete the square. So the which is like the thing we add to the equation in the parentheses is just b over 2 squared. So then it'll become 9 times x squared minus 4x plus 4 minus 4 times y squared plus 6y plus 9.
Right, and you have to add all that to the other side, right? So what is it
Yeah.
going to be?
So become 36 plus 36 plus minus 36.
Cancels
this
out, and we just have 36. So now what is this?
so then you divide both. Oh wait, maybe we first do like just simplify the quadratic equation. So it'll become 9 times x minus 2 squared minus 4 times y plus 3 squared. And then that is equal to 36. Then we divide both sides by 36 to get the a squared and b squared. So x minus 2 squared over x minus 2 squared over 4 minus is equal to 1.
Okay,
So
very good. So now we have the equation, right? So let me just erase all of this. So we have space to actually graph it. Okay, so now we have it, right? So first, is the transverse axis vertical or horizontal? William? The transverse axis. So remember, A is always under the positive function, so A is under x, which means it's horizontal, right?
yeah.
Okay, so it's going to be horizontal. So what is the center?
The center is 2, negative 3.
So why don't we, from this new center, create a new axis so it's easier for us, right? Just a new axis here. Call that x prime, y prime, whatever, right? So what is A?
A is 2 and A is 2, B is 3.
Okay, so and we know that A 2a, which is the transverse axis, is going to be what? Horizontal or vertical?
2A is gonna be
It's a transverse axis. Basically the major axis.
um
Well, it's under x, right? So it has to be horizontal, right?
yeah, horizontal.
So we go 1, 2, and then 1, 2 the other way. So this is it's going to be the transverse axis. Next, we have b is equal to 3. And that's going to go up and down, right? So 1, 2, and then 3. So 1, 2, 3 here. See how we've constructed a box, right? We have a box, right?
Yeah.
And what is c? First of all, c squared is equal to a squared plus b squared. So what is c squared?
C squared is 13.
C is equal to square root of 13. So we know that square root of 13, let me just use the calculator to try to approximate this. Square root of 13 is like 3.6. So to get the foci, we're going 3.6 this way and then 3.6 this way. See how we have foci 1 and foci 2 here?
Yeah.
Now we draw the asymptotes. Right? So these are the vertices because this is the transverse axis. So we're going to start from here and follow the asymptote. You see how we follow the asymptote here? We follow the asymptote. Do not cross it. The asymptote is there to guide your graph. Great. So now we erase everything, all this junk. See how we don't need this box anymore? It was never part of the graph in the first place. We don't actually need this stuff. So we can actually just erase all of this. Well, erase most of it. How much you want to erase? Just erase it. Of course, you can leave the box in, but it gets a bit messy on the iPad, so I'm just gonna erase it. So essentially, this hyperbola is gonna look like this, and the box and the asymptotes were there to guide your graph to make sure it looks realistic and good. Right. So now we go on to our next problem here. So let's just do these next few problems. So how about let's call someone else here. How about Sophia? Sophia, can you help me on this? Sophia, do you know how to do this? Well, you need to complete the square first, right? So how do we do that?
So
Remove the x's first.
you would factor 16 out of 16x squared minus 160x. Yeah, equals 0. And then you would complete the square. So that'd be 16 times x minus 5 squared minus 25 y squared equals equals 25.
Are you sure?
Equals.
You have to add 16 times 25 because actually inside the parentheses,
yeah.
so this is 400, right?
Yeah, 400.
Okay, so then you have 16x minus 5 squared minus 25 y squared. It's equal to 400. Okay, it's equal to 400. And we go up here. And you have to make sure this is equal to 1, right? So we divide everything by 400. So what do we get when we divide everything by 400? Over what? 16 over 400 is what? It's 1 over 25, right? So, and then we have just
25.
y squared over 16 here is equal to
Equals 1.
1, right?
Yeah.
Then we have a horizontal transverse axis. A horizontal transverse axis is quite helpful. We're used to that. So what is A?
A equals 5,
Okay, and B?
4.
Right. So we have the center here at what? It's 5, 0. So we have
Yeah,
A
5,
is equal to 5. So there's a vertex here, 5 here, and there's also B up 4, down 4. We create our box, make our asymptotes. Let me extend this so we can include the foci, and the foci is equal to what? 25 plus 16 is equal to, C is equal to square root of 41. Square root of 41 is kind of sketchy, so that's going to be equal to 6.4. So it's going to be here and here. That's F2 and F1. And we graph from these vertices here, right? See, so it's very simple. Because it's very similar to how you would graph an ellipse, except for that box, right? You have to get the A, get the B, find the C, right? And then you can basically graph the whole thing. So make sure you know how to draw the box. Otherwise, you have to actually like find the equations of the asymptotes themselves. Y is equal to plus or minus A, B, X, right? So make sure you draw that box. It's just much easier. And the third question here is find the equation of a hyperbola with vertices at 2, 3, and 2, 5 that passes through the point 4, 0. So one last volunteer who can help me on this. How about Zebo? Zebo, are you able to help me on this? No? Okay, how about Kaylee again then? Kaylee, can you solve this problem?
Okay, I'll try. So, well, first point put points at 2, 3, and 2, 5.
Very good. By the way, whenever I say vertices, this means these vertices are on the transverse axis. So if it were minor vertices, I would specify minor vertices. So it's transverse axis.
Okay.
That
So-
also means that the length from these 2 points is the transverse axis, which is 2a, which is equal to 2, right? So we already know a is equal to 1, right? So what's next?
So now that we know that's the major axis, kind of. So that's up and down. So the equation is y squared over a squared minus x squared over b squared is equal to 1. Oh yeah.
And we know a squared is equal to 1, right?
Yeah.
So now we just need to find the center, which is easy to do. What is this?
Yeah. You just put it in the
2, 4, right? So this is 4, 2. Okay, and then how do you find B?
middle. You plug it in for y and x through the point. So
This point, right? So,
plug in 4 for x and 0 for y and solve it.
Okay, so we have 4 over b squared is equal to 1. So it's 16 minus 4 over b squared is equal to 1. This one's easy. 16 b squared minus 4 is equal to 1. So b is equal to 5 over 16 apparently. That's kind of disgusting, but we'll take that. Hopefully that's correct. Let me check. If
Isn't
it's,
it b squared is equal to 5 over 16?
yes, b squared is equal to 5 over 16. Yeah, I forgot to write that. Sorry about that. But anyways, b squared apparently is equal to 5 over 16. So not the best number, but we can work with that. You definitely do not want to find never mind. Maybe it's not. Hold up. Is it let's see here.
Wait, I
No,
think
this is incorrect.
I think 16b.
16b squared minus 4 is equal to b squared. So this is bad. So it's actually the answer should be what? It's 4 over 15b squared is equal to 4. B squared is equal to 4 over 15. Yeah, sorry about that. So I forgot to multiply both sides, but now we fixed it. So it's still kind of an ugly number, but we can work with that. We really don't need b in the first place. We just need b squared. So that's great. Y minus 4 squared minus this 15x minus 2 squared over 4 is equal to 1. Right?
Okay.
So are there any questions, like any last minute questions about this topic? Because we are going to be moving on from this topic next week. Okay, so that's it, I guess, for this class. I'll see you all next week. So make sure you do your homework, and I'll see you next week.
Thank you.